Okay, we are going to talk about doing layout and taking the geometry from this drawing and transferring it to this piece of metal so that we can cut this shape out to the right size and shape. Okay, first thing I want to talk about is this ruler right here. These metal rulers, they measure, there is no zero on the ruler. Like plastic or wood rulers, you would have a zero mark, and then you would see the first mark on the ruler, and it would be zero. For these rulers, the edge of the metal ruler is zero. So the top marks and the bottom marks are different. If you can see close enough, it says here eighths and it says here sixteenths. So from 0 to 1 inch, the top part is broken into 8 sections. 8 equal sections. This is where your fractions come into play. So from 0, you have 1, 2, 3, 4, 5, 6, 7, and then at the 1 inch mark is 8. So it would be 8 eighths. And everybody knows that any number over itself is 1. Not 1 inch. One whole number. So just like if we kept counting and this was 8, 9, 10, 11, 12, 13, 14, 15, 16 eighths. Well, if you divide 16 over 8, right? How many times does 8 go into 16? 2. And so on and so on. So 16 eighths, 17, 18, 19, 20, 21, 22, 23, 24 eighths, which is equal to 3. Okay? At the bottom edge, it is broken into sixteenths. So if you count these hash marks, they were 16 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 sixteenths, or 1. Okay? This is why you need to know how to use a ruler and measure, because you need to take this information from this drawing and use the ruler and measure it correctly and mark it onto this piece of metal. Okay? So remember, marks are different on these rulers. The top is in eighths. You can see the smaller separation between, the larger separation between the lines, because there's 8 parts to this 1, 8 equal parts to this 1 inch. And on the bottom, there are 16 equal parts to this 1 inch. Why does it have eighths and sixteenths? Because sometimes you can measure an eighth if it's close enough to the 8th mark, right? But if you need a little more accuracy, you break it into smaller fractions, and you can get closer and more accurate with your measurements. Okay? So now this is our drawing. we have 3 by 4 3/4. That is the size of our metal right now. We cut at the squaring shear. So if we look at the metal and we just take this ruler right here and we just slide it right up to the edge of the metal, and we can see that this metal is 4 3/4 long, because we have 4 in 1, 2, 3, 4, 5, 6/8. And when you break down 6/8 into lower terms or simplify it, you get 3/4. So 6/8 equals 3/4. 4 3/4. The other thing you want to notice about these rulers is the line sizes. The lengths of the lines, right, determine certain things. If I'm starting from 4, the next line is 1/8. Can you see how the 1/8 mark is smaller than the next line after it, which is 1/4? So 1/8, 2/8. But 2/8 simplifies into 1/4. So the quarter line is a little longer. Then 3/8, then 4/8. 4/8 simplifies into a half, which the line is even longer than the quarters. Then you have 5/8, then 6/8, which is at the 3/4 mark, and you can see the line is a little longer. It's the same length as the 1/4, 3/4, and then 7/8, and then you're at 1 or 5 here in this case. So it's the same with the 16th lines. The 16th marks are the smallest marks, shadow, the smallest marks on the ruler. Then the eighths are a little bit bigger, so 1/16 and 2/16. The 2/16 marks reduces to 1/8, so 3 and 1/16, 1/8. Then 3/16, and then this line is a little longer, so you can tell that that's the quarter mark. That is 1/4. So that's 3 and 1/4. You can reference it right away just by the sizes of the lines. You can see that that's 3 1/4 right there. Because 4/16 simplifies into 1/4. Next would be 5/16 and then 6/16. Well, you can see that that's the same size as the 8th mark. So 6/16 reduces to 3/8. But it's a quick way, the size of the line, to reference that it's an 8th mark. So 1/8, 3/8, 5/8, 7/8. The smallest lines are 3 and 1/16, 3/16, 5/16, 7/16, 9/16, 11/16, 13/16, 15/16. Okay, you can tell by the sizes of the lines, and of course the half line is the biggest, other than the whole number, which goes all the way across. Okay, so that being known, if we wanted to measure this a little bit with a little bit more accuracy, we would look at the 16 marks. And you don't want to measure directly in the middle of a piece of metal, and I'll show you why. You may not be parallel with the edge, and that 1/16 could change. So that's why you want to measure the edges of the metal. So you can see that this piece of metal, the edge is right at the 3/4 mark. So this piece is in fact 4 3/4. Our measurement right here, 4 3/4. It's showing decimals. Some of these decimals, most drawings have decimals in them because they can go to 3 different places. And when you're manufacturing metal parts, you usually use a lot of precision, and you're going to learn that a little more later in the course of why we have to use so much precision metalworking. But you can see these are all in decimal. But it's easy also to see that that's a 1/2 inch, this is 3/4, and that's 3/8. Okay? And also, it does have an 1/8 here. And here. But it would be easy to recognize that an 1/8 is also 0.125 in decimal. So this piece I know is 4 3/4 long. So I'm going to measure the other side and make sure that this is at 3, which it is. So it's definitely at 3. Okay. So this piece of metal here, just make sure, first we cut it at the machine and measured it at the machine, but just to make sure, because the machine could be off, we measured and it's 4 3/4 by 3. Now we can start taking, now that we know this piece is good and is the same size as this outermost edges of this part, right? It'll be from here all the way around like this, with none of the features cut out of it. Now I can start transferring this geometry onto this piece of metal, because I'm sure that this metal is right size. So if you look at it this way, the orientation that it is in the drawing, let's look at the first measurement I see, which is right here, 0.5. Between these two extension lines, it's 0.5. So this is going to be the corner cutout. Also down here it shows me that from here down or from here up is also 0.5. So it's just a 1/2 inch square cut out of the corner. It's also 0.5 to this bend line. So I'm going to mark a line all the way down through. And if I want to help me remember that it's a bend line, I will make a dashed line. So the first thing I'm going to do is measure on the edge of the metal, and this is why we need Sharpies, right? We're going to use a Sharpie, but I'm also going to show you another technique. This thing that I've been using to point with is called a scratch-awl. Scratch-awls have pointed tips on them, hardened, sharp points, which can scratch into the metal. So you can almost use it like a pen and make marks in the metal. They are hard to see, but I will demonstrate. So I'm going to put my ruler on the edge of the metal, and on the edge of the metal over this way at 0, and I'm going to mark 1/2 inch, which is right here. You can see I made a little scratch with the scratch-awl. I'm going to do the same thing to the opposite side so that I can guarantee that the line I make up through here is parallel to the edge. So I made my line, my mark on the top. Now I'm going to go to the bottom and make another mark at a 1/2 inch on the bottom. That one's not as easy to see, but it is marked. It's just because of the light. See it better there. Now that I have the two marks both in from the edge, a 1/2 inch, I'm going to put my straight edge right along, and it might be easier if you keep your ruler on the bigger side of the metal so you can hold it down firmly. So I'm going to put my scratch awl on the mark and move my ruler to it. This way I know I'm going to start my mark right on my line, right on that mark. So I just put my scratch awl down and move my ruler to it. Then I can rotate the ruler down to the bottom mark and use how close I am to the mark with the ruler here as a guide of how close to get to the mark here. Because sometimes, depending on how you're holding the scratch awl, it might kick you out away from the ruler a little bit, especially when you're using a thicker tipped marker. But you don't want to be on this side of the ruler. The best way to mark is to take your point and point it into the corner of the ruler. Okay? Then I just push down a little firmly. Whoops, I don't want to move. Let me start over here. Point, touch, rotate to the bottom mark. Then press everything down firmly so it doesn't move. Press firmly with the scratch awl and you can make a mark. It's hard to see on the metal though, but you can see it in a certain light. If you were to look at this and the light was like that, when you were working on it, it would be hard to see the line. But you can see the line in certain light much better, like that. Okay? The difference between using the scratch awl, okay, and marking with the Sharpie is that the Sharpie will make the line much thicker. So if you can use the scratch awl and see your lines and marks, you will have much better accuracy, as you can see how thin that line is. It's just a scratch with the point. Okay? Now watch when I mark it with the Sharpie. And it all depends on how much accuracy you really need in your project. Can you get away with using the Sharpie, or do you need to have as much accuracy as possible? It's good to practice with the scratch awl, but the Sharpies are a good way to make quick marks and reference lines that are much better to see on the metal. And here I can also make some dashed lines so that I know that this is a bend spot. I'm going to bend the metal on this line. Alright, so we have our first line. Okay? Now I also have to do this 1/2 inch up. These bend lines. Here. And here. So it's 1/2 inch and 1/2 inch. 2 more 1/2 inch marks. Okay? So I have to go 1/2 inch down from this edge and a 1/2 inch up from this edge. And I'm just going to do it the same way. Making sure I always mark both sides of the metal from the edges. So, 1/2 inch. And then I can go to the opposite side. And mark 1/2 inch. And now I can just line the 2 points up with my straight edge. Put your marker down on the spot. Bring the straight edge to it. Rotate down to the bottom mark. And then you can see how I can see where the mark is on the ruler up top? That's how much I need to see on this mark to make it a straight line. And then I know that this one is solid, this line. And then from there down, I can do my dashed lines. See, so this line is solid. I can also go back and make sure that this line is solid. And do the same thing to the opposite side. Inch. Half inch. Okay, just turning the metal so I can put my ruler on the biggest side of the metal. My marker down on the mark, bring the ruler over, rotate the bottom to the mark, and remember, I want to see as much of the mark now I do here as I do down here. Okay, and then press lightly to make the mark, and I forgot to make it dashed, but that's okay because I'll remember. But press lightly to make your mark because you don't want to squish the tip of your point on your market, on your Sharpie. If you push hard, it's going to flatten that point on your marker, and you're going to end up with a big rounded edge on your Sharpie marker, and you're not going to be making very nice sharp lines like that. But I know that this should have been dashed right here to make me bend it. So what I could do now is just write bend line. Just so I remember. I don't want to come back here and start cutting this line, because I need to know that I bend it here. That's why we make some dashed lines. Dashed lines help us understand that don't cut this, bend it. Okay? Now this line I can make solid, because I'm going to cut that out. But I need to know that I'm going to bend this. Okay? That's our geometry right there so far. And these are not exactly the same size. They look close, but they're not. This drawing is not to scale. And what that means is that this equals this. They are not to scale. 1 to 1 would mean that this piece is exactly the same size of this drawing. It is not to scale. To scale would mean that the drawing is actually 3 inches. It's not. But it's close. Okay, so what else do I need to do? Well, what's my next dimension? I've got to do this line down the middle. So I have 1.25 here and 0.5 here, from here to here, and 1.25 from here to here. So 0.5 plus 0.125, which equals 1.75 from the edge to that mark. So I'm going to mark from my edges, from this edge, 1.75. So again, mark on the edges of the metal. .75, which is right there. And on the other side, .75, and it's easy to reference this 0.75 because of the 3/4 mark. That's the 3/4 mark right there, the longer one. So I know right there that I'm on the right spot just because of the size of that line. That's 1 3/4. So I have my 2 marks, and I'm going to remember now this time to make a dashed line. Marker on the spot, move the ruler over, rotate the bottom, and show as much of the dot on the bottom as I'm showing on the top. And make dashed lines. To show that it gets bent here. Okay, I have my corners. I have my 1, 2 vertical lines, 1, 2. I have my 1, 2 horizontal lines, 1, 2. Got to put the holes in. Okay, so how do I put those hole marks in? Oh, I've got in order to put the holes in, so I have to mark it. It's down from the top, 1 1/4. Down from the top, 1 1/4. So I'm going to have to measure along this edge down 1 1/4. 1, and I can see the 1/4 mark right there. That's 1 1/4. Okay. Well, I'm going to look how much right here while I'm here, from the bottom up, is 1 1/2. Now here's the trick with the ruler. If I want to go right to the bottom and measure, I can put the 1 1/2 mark right at the bottom edge. Okay? Just put the 1.5 mark right at the bottom edge and then mark the 0. That's 1.5 inches. Okay? So I have the 2 marks for how high up this mark is and how low this mark is. But I need how far in they are this way, which is this dimension. 0.375 times 2. 1, 2. Here and here. That's 3/8. So what I'm going to do now is measure the bottom to 3/8. Okay, and I can put my 3/8 mark right on the edge of the metal and then mark the 0. And then I'm going to go to the top because they're both in the same amount. And you know, sometimes when you're measuring this small amount, it's hard to get your ruler on the edge. And you don't have to use just the edge of the ruler. I can put this whole ruler right on the edge to make it easier. And then I can put it on the hole mark at the 7. And it doesn't matter because I'm still 1, 2, 3/8 from that mark. Okay, so that's 3/8 from here to here. Now that I have a 3/8 mark at the top and a 3/8 mark at the bottom, I can line up those 2 marks and then just make marks where my other hole mark locations are. So here, I'm just going to make a mark a little bit. And down here, I'm going to make a mark a little bit. Okay, so I know it's only around where the hole is going to be. I don't have to make a line all the way down, only just where the hole is going to be. Like that. Now I have another tool that we can use to make the line the opposite way. So if you have a short enough line to make, I didn't have to make a mark at the opposite side of this sheet metal because I have what's called a square. I'm going to take my square and put my metal on it like this. Okay, there's a ledge that the metal lays on like that. Okay, and I'm going to hold it up on the back, and then I can slide the metal on the square and slide it right up to my mark, and this will make a perpendicular line to the edge of the metal. So I just have to line up the edge of the square at my mark, I'm trying to get you in the light here. like that. And you have to make sure you're on the square, all the way flat. Make sure you're not rocked. So make sure it's square. Find your mark. Hold it together. Pinch the metal to the square. And then just mark your spot right across. And that one marked a little bit high, but okay. Same with the bottom. Okay, and then you would make your hole right on the intersection of that little plus mark. So that sets the location of our holes. The last thing we have to do with this is these two angle marks that create this notch out right here. And it is 90 degrees. Okay? This angle opening is 90 degrees. Which means if I cut it in half, each side is 45. Okay? These squares can not only do 90 degrees.
Mrs. Kellner, if you're available, can you come to the athletic office?
These squares can not only do 90 degrees, but they can do 45 degrees here. And that way is just putting the 45 edge on the edge of the metal. And then I can scribe a line along that in a 45, or even this side. So I need to put them here, okay, from, you can actually even go to the opposite side of the metal. And you can see that I still have a 45 right here. So I'm going to line it up that way and scribe my line right here. Then I can turn it the other way. And scribe my line right there. I'm going to make the other line a little darker. Didn't get quite dark enough. Yeah, that's better. Now I have my 90-degree mark. I just need one more on this side, and I'm just going to do it the same way. And it's done. One last thing you can do is to help you see what's happening here is you could shade in or mark off the parts that get cut out. So as you can see, that gets cut out. That's going to get cut out. This will be cut out. And this corner will be cut out. Once you cut all this out, you can bend it. But before these triangles get cut out, the holes need to be put in at these intersections of the bends, where it says punch out 2 bend reliefs here and here. This way, when it's bent at these corners, the metal won't all push into the corner and get deformed. So that is it, and you could put other notes on this too. You could mark and say what size hole. Just so you know, but you also have that information right on your drawing. So 1/8 inch punch in 4 locations. 1, 2, 3, 4. 1/8 inch drill or punch here and here. 1/8 inch punch or drill here and here. Lastly, so you don't forget the angle, if you have weird angles, you could make notes or directions that you bend the metal, because sometimes it's not always up and 90 degrees. You can make a little note, bend up 90 degrees. And what that means is it's going to be bent from here, and this part, let's see, I'm going to show this. So this part here will be bent up like that. So this, they call it a wall, a bend wall. From here to here would be bent up like that, rather than down, which would go down this way. Okay, if you're looking at the side of it, up, the wall would be bent up here, and down, the wall would be bent down here. Does that make more sense? So you could, but this one you can see that they're all up 90 degrees. And this will be your first practice piece. Once you do all the layout, once you cut your piece, once you cut your stock piece and do all the layout, you'll be ready to cut the other pieces off, which I'm going to show you how we do that. Punch the holes, which I'm going to show you how we do that in the next video. And then bend these 4 bends. 1, 2, 3, 4 in the next video.